Okay, moving on with our discussion of the circles, we say that three non-collinear points, that means that they don't lie on a straight line, enable us to find the equation of a circle if we know their coordinates. So I'm going to do a numerical example here to find an equation for the circle which passes through the points whose coordinates are 1, 7, 2, 5 and minus 3, 4. Well, we begin by writing down the general equation for the circle, x squared plus y squared plus some constant times x and another constant times y and a third constant not involving x and y. And then substitute in the coordinates. First we'll do this one here, 1, 7. So that will give us 1 plus 49 plus a plus 7b plus c equals 0. We call that equation number 1. And then do the same with the points whose coordinates are 2 and 5. What will that give us? 4 plus 25 plus 2a plus 5b plus c is 0. Call that equation number 2. And last of all, using the coordinates minus 3, 4, you'll get 9 plus 16 minus 3a plus 4b plus c equals 0. That's equation number 3. Before we go any further, just tidy those up. So the first one will be a plus 7b plus c equals minus 50. The next one will be 2a plus 5b plus c equals minus 29. And the last one will be minus 3a plus 4b plus c equals minus 25. So the problem now is to solve those three simultaneous equations to find out what a, b, and c are. Now that can be done using matrix methods, but as you may or may not have done those, we'll try and do that just using simple elimination, as we do with when you just got two equations. So we'll try to eliminate one variable first, and let's see how we can do that. So if we subtract, let's say, the second equation, well, first of all, actually looking at those, if we add all those three equations together, adding all those three equations together, the a's will disappear. That wasn't intentional, but that seems to just be a happy accident. Okay, so that gives us 16b plus 3c equals let's see, minus 75 minus 104. Right. So that gives us an extra equation. We now want to eliminate the a from two of them, so that we just get another equation with b's and c's in it. So if we take the first two equations and double the first one, that will be 2a plus 14b plus 2c equals minus 100. And then in other equation, we've got 2a plus 5b plus c is minus 29. And let's see what that gives us when we subtract. It gets us 9b plus c equals minus 71. We can now, let's say, call that equation number 4 and number 5. So we have equations there with just b and c. So let's write those down. 16b plus 3c equals minus 104. And let's multiply equation number 5 by 3. So that gives us 27b plus 3c equals minus 213. Yes, okay. So 213. And now subtract. We get 11b equals minus 109. That's subtracting the top equation from the bottom. And that means we now have b equals minus 109 divided by 11. Right. We'll now use equation number 5 to find c. c is minus 71 minus 9b, which is minus 9 times 109 over 11. And that will bring us down to c is 200 divided by 11. Just now remains to find a. Well, let's see. Substitute in any one of those equations, 1, 2, or 3. We get a plus 7b, which is minus 109 over 11 times 7, plus c, which is 200 over 11, equals minus 50. Let's see what that comes down to. So a will be minus 50 plus 763 over 11 minus 200 over 11, which is minus 550 plus 763 minus 200 over 11. And that comes down to, I think, a is 13 divided by 11. X 750, yes. Yes. And then we now plug those back into the original equation. So what did we have? We had x squared plus y squared plus 13 over 11 x b minus 109 over 11 y plus 200 over 11 equals 0. You can tidy that up by multiplying up by 11, but I think I'll just leave you to do that. And thank you for listening.